Tubers, students of organic chemistry, Dave out in Western Pennsylvania, USA. Note the virtual organic chem lab. I've done some prior videos on this. I think I've done 6 now. And I'll be teaching Organic One Laboratory this summer, 100% remote because of the pandemic. It will include some instruction with the virtual organic chem lab here, among some other items. What I want to do to familiarize you with this program, viewers and my students alike, we're going to attempt to do a Friedel Crafts alkylation here. So we have some choices up here. And what I'm going to do is start with benzaldehyde, a deactivated meta-directing aromatic ring. Double click to put some in the round bottom. You can try to bring a syringe over and penetrate the rubber septum, but I always have trouble with my Mac seeing that, so I double click. And I'm going to also take benzoyl chloride as my, so this is going to be a Friedel Crafts acylation. Double click. They're both in there. Do you see the blackboard? And we need a solvent, a nonpolar solvent. We'll use diethyl ether. And all 3 are on the blackboard. We then L-drag the round bottom to the plate, the stir heater. Don't forget the catalyst, aluminum chloride. Double click. It's up on the blackboard. Okay, heating mantle. Gonna have to heat this. Reflux condenser. Nitrogen gas. Start the reaction. Note 7:43 is the time of start. Time 0. I'm going to do a TLC. Okay, and you can see that we have some 3-benzoyl benzaldehyde forming. Do you see the blackboard along with hydrochloric acid? And so the reaction is underway. Starting material is over here, and this is the reaction progress. Okay, I'm going to go up an hour. And you can see if I let it go that long, I took a chance, because if you go beyond the reaction rate, the glass could explode, to teach you to allow the reaction to progress at a decent amount of time. But you can see now that the starting material has been used up. And you can see the structures of these on the blackboard by putting the L button on the mouse. Diethyl ether, aluminum chloride. In real practice, if you're going to do a Friedel Crafts acylation or alkylation, always take a little pinch, a spatula full of aluminum chloride, throw it in the sink. Listen carefully. If it hisses, the catalyst is dry and ready to use. If it does not hiss on contact with some water, it's wet and it's not going to work well. Okay, and there is your target molecule, your product. You can see it's 3-benzoyl benzaldehyde, which happens to be, if you look up the melting point, it's a solid. Okay, what do we do now? We click on the SEP funnel. We're going to do a workup. And we have acid there to get rid of, right, from the aluminum, the Friedel Crafts acylation to actually a very dirty reaction. We're going to click on the aqueous sodium hydroxide. And if we go to the SEP funnel, the lower layer has the aluminum hydroxide, sodium chloride, HCl residual, and water. We want that top layer, which has the solvent, diethyl ether, and 3-benzoyl benzaldehyde. Now, what we're going to do is bring that over to a round bottom. And the ether has been rotovapped off, not shown. And what you have in that is your 3-benzoyl benzaldehyde. Now, it is a solid. So what happens is you bring that over to the crystallizing dish, and that will remove all of the ether. You don't distill it. It's a solid. At atmospheric pressure, it would decompose. There's your solid, and it's your compound. Now, watch what we're going to do. We're going to do FTIR for the target molecule, the product. You could save that to the notebook if you wish. You know, we could definitely hit save. And let's check the notebook. There it is, FTIR. You would fill in the reaction, the time, that it went. Okay, I'll X out the notebook and click OK. Now, let's do a C13. There's your C13 chemical shifts. Those are proton decoupled, and shows you the different types of carbons, including carbonyls down here. Way downfield are your carbonyls in the C13. So that's okay. Let's do proton. We click on the black. Let's do a proton spectrum. And you can see the heavy aromatic signals, and they're integrated. You don't integrate C13, you integrate hydrogen. I don't want to get into why that is, but I got my PhD in 1980, University of Nebraska, Lincoln. It seems like, 40 years ago. And I did 3 and 4 membered heterocycles with the late Professor Norman Cromwell. Incidentally, Professor Cromwell's first graduate student was D.J. Cram, who later won a Nobel Prize in chemistry, host-guest chemistry. After 4 years with Allied Signal Corporation, now Honeywell, I was a senior research chemist. I joined the University of Pittsburgh, Bradford, and I've been a chemistry professor here since 35 years. Okay, I'm going to click OK on that. I just love this, considering my age and how long I've been in organic. My advisor would have loved this, see this. What else are we going to do? We're going to do a mass spec. Fragmentation pattern. Here's another interesting one where the base peak and the molecular ion are one and the same. And then the melting point. Now, what you do with this solid, you just click on that, bring that over. Let's see if I can get it. There it is. Melting point is 131 Celsius. You did a good job with this Friedel Crafts Acylation, and I hope you enjoyed this. And pretty soon we'll do some more of these reactions. I'll upload them, and then we'll do organic structure determination with this. And I'm teaching organic analysis as an upper level course this semester. I'm finishing online, of course. All right. Now, this is how you leave. You hit the exit. And then up in the right, you hit exit. We didn't save anything in the notebook, so I'll click OK. And guess what?